For almost a decade, scientists chased the source of a deadly new virus through China's tallest mountains and most isolated caverns. They finally found it here, in the bats of Shitao Cave. The virus in question was a coronavirus that caused an epidemic of severe acute respiratory syndrome, or SARS, in 2003. Coronaviruses are a group of viruses covered in little protein spikes that look like a crown, or corona in Latin. There are hundreds of known coronaviruses. 7 of them infect humans and can cause disease. The coronavirus SARS-CoV causes SARS, MERS-CoV causes MERS, and SARS-CoV-2 causes the disease COVID-19. Of the 7 human coronaviruses, 4 cause colds, mild, highly contagious infections of the nose and throat. 2 infect the lungs and cause much more severe illnesses. The 7th, which causes COVID-19, has features of each. It spreads easily, but can severely impact the lungs. When an infected person coughs, droplets containing the virus spray out. The virus can infect a new person when the droplets enter their nose or mouth. Coronaviruses transmit best in enclosed spaces where people are close together. Cold weather keeps their delicate casing from drying out, enabling the virus to survive for longer between hosts, while UV exposure from sunlight may damage it. These seasonal variations matter more for established viruses, but because no one is yet immune to a new virus, it has so many potential hosts that it doesn't need ideal conditions to spread. In the body, the protein spikes embed in the host cells and fuse with them, enabling the virus to hijack the host cell's machinery to replicate its own genes. Coronaviruses store their genes on RNA. All viruses are either RNA viruses or DNA viruses. RNA viruses tend to be smaller, with fewer genes, meaning they infect many hosts and replicate quickly in those hosts. In general, RNA viruses don't have a proofreading mechanism, whereas DNA viruses do. So when an RNA virus replicates, it's much more likely to have mistakes called mutations. Many of these mutations are useless or even harmful, but some make the virus better suited for certain environments, like a new host species. Epidemics often occur when a virus jumps from animals to humans. This is true of the RNA viruses that cause the Ebola, Zika, and SARS epidemics, and the COVID-19 pandemic. Once in humans, the virus still mutates, usually not enough to create a new virus, but enough to create variations or strains of the original one. Coronaviruses have a few key differences from most RNA viruses. They're some of the largest, meaning they have the most genes. That creates more opportunity for harmful mutations. To counteract this risk, coronaviruses have a unique feature, an enzyme that checks for replication errors and corrects mistakes. This makes coronaviruses much more stable, with a slower mutation rate than other RNA viruses. While this may sound formidable, the slow mutation rate is actually a promising sign when it comes to disarming them. After an infection, our immune systems can recognize germs and destroy them more quickly if they infect us again, so they don't make us sick. But mutations can make a virus less recognizable to our immune systems, and therefore more difficult to fight off. They can also make antiviral drugs and vaccines less effective because they're tailored very specifically to a virus. That's why we need a new flu vaccine every year. The influenza virus mutates so quickly that new strains pop up constantly. The slower mutation rate of coronaviruses means our immune systems, drugs, and vaccines might be able to recognize them for longer after infection, and therefore protect us better. Still, we don't know how long our bodies remain immune to different coronaviruses. There's never been an approved treatment or vaccine for a coronavirus. We haven't focused on treating the ones that cause colds, and though scientists began developing treatments for SARS and MERS, the epidemics ended before those treatments completed clinical trials. As we continue to encroach on other animals' habitats, some scientists say a new coronavirus jumping to humans is inevitable. But if we investigate these unknowns, it doesn't have to be devastating. Students and teachers all over the world did their part to help slow the spread of COVID-19 by staying home. But what about their graduation ceremonies? Learn more about TED's global campaign to celebrate and elevate the hopes and ideas of an entire generation. Get involved at ted.com/graduation.